Hi, everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human-Centric AI Podcast, where each episode we feature thought leaders doing cutting-edge work in the AI space. A little about us. SmartEye is a global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments, bridging the gap between humans and machines for a safe and sustainable future. Today, our technology is embedded in next-generation vehicles, leading the way towards human-centric mobility through driver monitoring systems and interior sensing solutions. Our research instruments offer unparalleled insights into automotive, aviation, assistive technology, behavioral science, and many more fields. In today's episode, we dive into the world of eye tracking technology and how it's transforming the landscape of human factors research setups. We covered why eye tracking is more applicable than ever, hosting 3 expert speakers from the University of North Dakota. Furthermore, iMotion spoke on the multimodal approach for enhanced insights. Let's listen in to learn more. Okay, welcome. Thank you all so much for joining us for today's webinar, Expanding Human Insights, Combining Eye Tracking with Biosensors to Assist University Research Labs. My name is Ashley McManus, and I am the Senior Director of Global Marketing at SmartEye. So SmartEye's mission is to revolutionize the human-machine interaction, and our technology helps researchers understand the cognitive processes that guide people's behavior and decision-making. So our data-driven insights offer a deeper comprehension for the human mind. And what I'd love for today's presentation to convey is that this technology is being used in research labs for universities today. The featured case study for the University of North Dakota, or UND, will break down not only how they arrived at SmartEye for their Research Institute for Autonomous Systems, or RISE Labs, automotive research use case, but also will address what the fusion of multimodal sensors between SmartEye and iMotions was able to help them understand about the driver in their test vehicle. So I hope today's event will inspire some ways eye tracking can be integrated into your research setup, whatever it is that you are studying. So with all that being said, I am thrilled to host our expert speakers today. We have quite a group. We have first up our own Rob Wesley, North American Sales Director in SmartEye's Research Instruments Division. We also have Nam Nguyen, Technical Partnership Manager and Senior Neuroscience Product Specialist at iMotions. Philip Brandt, Senior Research Scientist at UND RISE. Montel Williams, Postdoctorate Research Fellow at UND RISE. And Richard Ferraro, a Distinguished Professor of Psychology at UND. So I'm going to have Rob begin now, who will give a more comprehensive introduction of himself, SmartEye, and the wide-ranging applications of 3D remote head and eye tracking in research labs. And I will see you all at the end. So Rob, take it away.
All right. Thanks, Ashley. So just to provide a little bit of background information, when I first got the call from Phil about this project, we were really excited. I mean, first of all, it's testing in a Humvee. I mean, that itself is pretty cool. And some of the things that Phil mentioned was that they wanted to do eye tracking both inside the vehicle on the vehicle instruments as well as outside the vehicle on the terrain. But they wanted to test the driver and passenger simultaneously. They wanted to be able to test in sunlight, in darkness. They wanted the driver and the passenger to be able to wear glasses or sunglasses. And furthermore, they wanted to be able to test in live drive scenarios in rugged terrain. In addition to this, they wanted to deploy other biosensors such as EEG, emotion sensing, as well as other sensors down the road. So really, this is the perfect application for a SmartEye Pro multi-camera system combined with the iMotions biometric platform. So first of all, SmartEye Pro. What is SmartEye Pro? SmartEye Pro is a 3D remote multi-camera eye tracking system. So first of all, what does that mean? What does 3D remote multi-camera mean? 3D refers to the usage of a world coordinate system. So if you look on the right-hand side of the screen, what you'll see is a 3D wireframe. And essentially, this is a replication of the test environment, this case being the test environment of a vehicle. So what you can see there, you have a red rectangle. That is the windshield. And then you see a green circle that indicates the driver's head. And you can see the gaze origin dot inside the green circle. And that gaze origin has a gaze vector that is coming down and intersecting the windshield. So you'll notice the little blue dot there in the windshield. Also in that 3D world coordinate system, you'll notice other items within the vehicle. So you can see the left mirror, the right mirror, the tachometer, speedometer, all those items are named. You can even see the small crosshairs that indicate the location of each camera, the yellow dots that indicate the infrared emitters. And you'll see a large axis there that shows the center of the world origin. And this is the XYZ000 point within that vehicle. So everything in your data is measured off that point, and you can make that point any place you want. Now, in the UND case, this was very useful because they wanted to do simultaneous driver passenger testing. So they were able to use one single point as the world coordinate origin. So the data for the driver and the data for the passenger are all measured off that same point. So it makes it very easy to use your data. In addition to this, a lot of eye trackers will just simply tell you where the eyes are located and where the gaze vector is, but they leave it up to the researcher to figure out what is that gaze vector intersecting. Smart Eye goes a step beyond that. We actually tell you what that gaze vector is intersecting. We'll tell you it's intersecting the windshield, the rear view mirror, things like that. So it greatly simplifies the process to utilize that data. I didn't touch on remote yet. Simply remote means the cameras are placed at a remote location within the vehicle, often hidden. But what makes this really unique is it allows you to test with people with glasses or sunglasses, which makes it very helpful. You don't have eye tracking glasses slipping down your nose. You don't have wires attached, so it makes it much more comfortable for your testing and naturalistic. In the last step, it's a multi-camera solution. So in the case with UND, they wanted to test from side mirror to side mirror. Now the Humvee is a wide vehicle, so we had to deploy 3 cameras. They wanted to test the driver looking down towards their lap as well as up. So we had to deploy 5 cameras in this case. And then for the passenger, we deployed 4 cameras. So it's a very flexible solution that allows you to test in a multitude of environments. So what makes the Smart Eye Pro camera unique? I mentioned it's a multi-camera system. It runs on a single PC. It's scalable all the way up to 8 cameras. So that allows us to test in a wide array of environments. You can place the cameras horizontally, vertically, diagonally to match whatever environment you may be testing in. So sometimes you can test in a simulator, then later on you can move the system into a vehicle and test it in a vehicle as well. The test subjects can be from 30 centimeters away from the cameras all the way up to 3 meters away. So it does give you a lot of flexibility there as well. The Smart Eye Pro system provides the best combined head box, field of view, and gaze accuracy on the market for remote eye tracking systems. In fact, Smart Eye systems have been used by many automotive manufacturers as their reference system to release and to design and develop production systems. Also, as I mentioned, we utilize the 3D model to replicate the test environment, which simplifies the post-processing. And the Smart Eye Pro system is capable of providing over 145 different head and eye measurements. So this would include the eye location, the eye openings, the blinks, blink velocities, as well as your gaze vectors, pupil diameter, and so forth. And lastly, the system is insensitive to ambient light, which allows us to test in sunlight, allows us to test in complete darkness. So this is a video where we are incorporating the Smart Eye Pro with another tool called Smart Recorder. When UND came to us, they wanted to test inside the vehicle to look at all the instrumentation, and then they wanted to test outside the vehicle as well, looking at terrain. So what we did, in this case, we're showing a 4-camera system. You can see I'm looking around to different instruments, and even as I move around, the gaze doesn't float with my head movement, which is very nice. So even as I'm moving side to side, forward and backward, you can see how it maintains accuracy. And then what we can do is we can incorporate the Smart Eye Pro tool. This is the same system utilizing the Smart Recorder tool for recording outside the vehicle. So this allows you to overlay the gaze onto a simple webcam image, and you can identify items that are being viewed outside the vehicle. So in this case, you'll see I'll look at the mailboxes on the left. There's a water tower, so I'll hit 1, 2, and 3 mailboxes over onto the hydrant, onto the for sale sign, and then onto the oncoming traffic. So in this case, we're utilizing the iMotions tool, the iMotions biometric platform, to run the Smart Eye Pro system. So this is very unique that the integration is already done for you. You have the iMotions biometric platform connected to the Smart Eye Pro system with the smart recorder, and we're also running the emotion module all simultaneously. So in this video, this is actually within the Humvee. We have a 3D model of the Humvee, so you can see where Isabella's looking at throughout the test, but we're also tracking her looking outside the vehicle. So when she looks outside the windshield, you can see where she's looking at on the train. In addition to this, we're tracking her 7 basic emotions. So they're looking at emotions like joy, anger, surprise, contempt, all simultaneously. And you can add and combine additional biosensors such as EEG, ECG, and GSR. So to give you a little more background on the iMotions tool, I'll pass it off to my friend and colleague, Nam.
Thank you so much, Rob. Hi, everybody. My name is Nam Nguyen, and I'm a senior neuroscience product specialist at iMotions. And I'll be unpacking a little bit more about our role in this project, as well as some of the tools and technologies and why they are interesting to use for these type of research. So iMotions is a software that basically integrates various types of tools, and we're used in over 1,000 sites right now from some of the world's leading academic organizations, as well as commercial and enterprise laboratories for collecting data and understanding insights from the human experience. So the first question that I want to ask is like, why even do multimodal research? What's the point of collecting these types of data, and what does it actually add to understanding how people are interacting with things like navigating a route or understanding the learning and memory of a particular set of instructions? We'll see that the human body has a variety of systems that are interacting with them that can be sampled for various types of insights, such as the eyes to understand where people are paying attention and learning from where the information is being gleaned from. The face can give you insights into the person's emotional state, things like concentration or confusion, or other things that might come into play in terms of the human experience. Other situations such as muscle activation, brain, skin, heart, and voice can all give really interesting insights when it comes to questions like workload, activation, relaxation, and other types of things that are very important during specific events. We'll see that the way that we work is that we're able to take data from a variety of fantastic tools, such as the Smart Eye Pro for eye tracking, and then combine that with other tools that will give insights into things like watches, camera-based facial expression detection, devices that will be able to link onto the head to look at EEG brainwaves directly. We're able to take all that information and then synchronize that together into a single recording so that you can then see what people were paying attention to, how they responded, and how much they responded in any moment. When you combine that with things like video recording, camera recording, and things like the smart recorder, we're able to then synchronize that to a variety of complex environments never before done before. We then have a variety of tools for things like analysis, importing, and then exporting it to these types of things. So if we look at a couple of these environments, you can see here is an example of a variety of different tools and environments that iMotions currently supports, whether they're out in the field, inside a store, inside the virtual environment, inside the cockpits of a car, in this case, which is the most relevant for this project, as well as on-screen support and applications. And then we're able to combine them with both wearable devices, remote devices, as Rob was mentioning before, things that are not attached to the body, as well as a variety of things built within the system. Each of these devices have pros and cons in terms of simplicity, cost, as well as the ability to naturalistically respond to certain environments. And depending upon the research questions, in this case, the naturalistic environment was absolutely paramount. So we wanted to make sure as much as possible was remote. We're just going to first unpack exactly what you can get from a system like eye tracking and what it actually helps the researcher to understand. So from eye tracking, you're able to, regardless of the system you use, essentially from our software, understand exactly where people paid attention and where they didn't pay attention. And you can look at this through a variety of different visualization, such as gaze plot replays, which is what you see in the middle there. You can then look at the way that people actually distribute their information across time. So looking at the heat map will give you an average of where attention was given and what areas were ignored. Therefore, then you can change your designs or your protocols to help drive attention towards more appropriate areas or ignore things that you don't want them to see. Finally, of paramount importance is the quantitative information, and that can be done through a variety of different outputs, such as areas of interest and other tools to look at things like time spent, looking at a particular area, such as dwell time, time to first fixation, which is what was looked at first, the ratio of percentages of what people look at and what they ignore, and a variety of other tools that can get quite deep into the ways that the attention processes work from a human being towards a particular set of circumstances. We can see that that attention is a very powerful tool, especially when it comes from a tool that allows you to do it very naturalistically, like the Smart Eye Pro. But then you can combine that with the what they reacted to how they're actually reacting. So things like facial expression analysis, which can be done through camera-based systems, just like the ones that we're using right now for this webcam, can go through AI-based softwares that have huge validation databases, such as the 14.7 million faces that the Affectiva AFTEC engines utilize currently, to then very accurately assess the particular facial expression response that a person is making moment by moment as they're experiencing something. In this way, when they're paying attention to some aspect, you can get some understanding of things like joy, fear, contempt, sadness, as well as just the individual facial movements and the way that they're turning the head. All of these combines to a deeper insight of what they're reacting to and then how they're reacting. If we move on to the final type of information that was used for this particular project, we might take a look at things like EEG, which is known as electroencephalography. What this is a methodology for using a device to directly sample the electrical activity coming from the brain through the scalp. So essentially, it's a hat you place on that has a variety of different antennas that will then sense the electrical activity of the tissues underneath. What we're able to do is take that information and then through a variety of recording and then analysis on the back end, we're able to take those signals and then decrypt them for various types of things that are associated with certain cognitive responses. Traditionally, these are things like distraction, drowsiness, workload, and a variety of other situations that might be really interesting when it comes to answering questions about training, involvement, overload, and other things that researchers such as Philip here is interested in. That wraps up my presentation for the iMotions involvement, and we'll actually look at these in play with the University of North Dakota with Philip.
Hey guys, hey, thank you very much, Nam. Thanks, Rob, and thanks, Ashley, for kicking us off here. I'm Philip Brandt. I go by PB. It's not for my initials. It's actually for Polar Bear. That was my my call sign when I was on active duty. So I have been with RISE for close to 4 years now. Prior to that, I was assistant professor for about 5 years at the University of North Dakota School of Aviation and Aerospace, and before that, I was an active duty military officer and aviator, retired as lieutenant colonel. My background is not as a pure scientist, not as a hardcore anybody in human factors, but the last part of my career really was dealing with a very autonomous system, and so that led me into academia because of UND's broad reach here that you can see under their colleges and schools, and then into the Research Institute for Autonomous Systems that really is looking at these finer points of how humans and machines and autonomous agents really come together and improve our society, and what elements do we need to be looking at in particular to help that merge of human and machine really happen well. I will need to caveat here that the views myself, Dr. Williams, and Dr. Ferraro are going to address are our own as private citizens. We do have ongoing research that we can't specifically talk about, and we do not speak in this matter for the university or for RISE or for the state. To talk about why and how UND got into this process of selecting Smart Eye and iMotions, I want to take 2 steps back. What we're looking at here is Colonel John Boyd's OODA process. It's not an OODA loop. It's very much a process or a systems of interactions between very detailed factors. This is taken from his brief, The Essence of Winning and Losing, that he put together at the end of his career. And this, since I'd known about OODA throughout my entire career, but really the details of this diagram and the finer points of it really came to light when I started flying the Global Hawk, the RQ-4, because I wasn't flying it. I was literally working with a robot teammate that was designed by the original designers for one human to fly 3 at once. I really had to understand how the robot was thinking for me to max perform our partnership and achieve the mission outcomes. And this diagram, this single source diagram, was always on me or near me at one point when I'd either be operating myself, teaching, instructing, evaluating, anything, because it was very, very easy to identify how every individual approaches their relationship with the robot a little bit differently. Why this really matters, especially with our work with RISE here, is that every human arguably is undergoing the OODA process continuously. And there's a lot of variables that go into the background. Arguably, you can say the same thing about the machines and our ability for machines now to remain state aware, monitor the environment, do what they're programmed to do, and have biases in that programming. But at some point, we want those two sides to come together. And we want to produce what I like to refer to as the singularity. And in human factors terms, how I define the singularity is the optimal state of human and machine working together. Now, the challenge is that clearly on the left side, there needs to be a hierarchy at certain times. Sometimes actions need to happen so quickly and rapidly, the human can't be asked for permission or concurrence. They just need to be told afterwards what happened. The robot took care of it. Other times, like the use of force or escalation of force to lethal effects, we're not there as a society to have a robot make that decision. There will always be a human in that hierarchy, at least for the immediate future. So when you're looking at that, you also need to look at the other side. Is there just need to be a clear division of labor? Not everyone can be an expert in everything. So maybe you go, hey, I'll learn about this, robot, you learn about that. We'll meet in the middle, and that'll define our singularity. But I think there's a more optimal way to go about that. And that is really what drove us to our relationship with Smart Eye and iMotions. So this is what we can talk about. This has been approved for public release. This is a UND Today story that's available on the web. The link is right there, and there is a several-minute-long video that highlights really, really nicely the work that we're doing in the Humvee for this project. So any details about the project, I'd say just please go there. What I'd like to say is, like Nam and Rob have discussed, it is amazing the insights that we are getting about the human as they operate with other humans in the team, and also when they operate with certain agents that we are employing in our scenarios and building into our systems. We really are looking for that optimized state awareness of the human and asking these follow-on systems to go, hey, stop making the human bend to your capabilities. We are smart enough now to build systems that can start adapting to the human at their current state in real time to optimize the interaction and optimize the human's output. And this platform is really allowing us to go forward and start unlocking those questions, unlocking the answers from those issues, and realizing how big a problem set this really is at an experiential level. And that just makes me really, really excited about what we can do. So I can go on and on about this because, one, I'm a pilot, and two, I'm an educator. But to move us along, when I hand it over to Dr. Williams to talk about where we're going next or why he's most excited to have access to these tools, and then we'll finish up with Dr. Ferraro with a quick overview in the history of eye tracking and like the changes he's seen in his 30 years of being an educator and a psychologist. So, Dr. Williams, over to you.
Hello, my name is Dr. Williams, or you can just call me Montel. I'm a recent grad from Virginia State University. I'm also a recent draft pick from UND as well. I currently work with them as a research associate. I do like Smart Eye and what they can provide because initially when I graduated, I kind of had these biases regarding being able to do psychological research, that there wasn't going to be much of a combination, so to say, between AI and the human, psyche. And being able to come into RISE and UND has really shown me that maybe a good number of my views were archaic in nature. And so I do appreciate being able to be drafted and pulled in to be able to work with RISE as well as UND to work on certain subjects, while still giving me the ability to look at certain social aspects of academia, because my psych degree, because I'm under psychology, my psych degree is under behavioral and community health. So mine is more premised towards the social aspect of psychology rather than neurology or AI. And Smart Eye really gives me an ability to basically still look at all those things. As Nam said, I can still look at emotion, I can still look at stress, I can still look at facial recognition and still get honest responses and not be bogged down by, paper questionnaires. So for some of the future projects that I wanted to work on, I do want to look at focus and attention span in college students because in my history, typically whenever we try to do projects with college students, they tend to just give you whatever response you want to give so they can get done and get their incentive and move on. But with this eye tracking data, we can get actual honest responses, right, without being bogged down by paper, as well as being able to get a genuine, true reaction to stimuli. Because also in my academic history, I premised stress and more or less coping strategies, especially when it comes to cardiovascular reactivity. So getting an honest response in how people deal with stimuli is just as important as the aspect of what do we do when they respond to those stimuli as well. Speaking of which, I also want to go into emotional regulation. I want to look at a response to stressors because that's also part of my history, and I probably won't ever be able to get away from it. And also want to look at informed decision making, especially when it comes to social ability and communication with different age groups and different social groups. And the reason I bring these up is because these are all more or less smaller projects leading into my quote unquote big project, the main thing I'm interested in, which is centered around empathy. So my general goal is to create at least one significant intervention regarding being able to both teach and practice empathy between us as individuals. Because long story short, I feel like that is sort of starting to disappear in our society. So I want to help fix that. And eye tracking gives me an ability to, as I said, give me an honest representation where people put their information, where they focus their information, where they focus their attention, and be able to perceive certain stimuli in reality while also remaining honest about it. Right? Again, you are not going to be able to just make or fill in a couple of bubbles in a questionnaire and think that qualifies as an honest response of how you generally feel. And so eye emotions gives me that ability to get an honest response in that sense. And I also particularly want to study certain social groups because these are the groups that tend to basically uphold the entirety of our society. So military for once, which is obviously a little bit more geared to where I am with UND. College students, which I have a history of, and now I can get, like I said, get an honest response from them instead of just whatever they want for the incentive. And then I also want to look at employees. And so I know that seems a little vague, but when I say employees, I do generally mean anything from white collar to blue collar, people who are putting in 9 to 5, your graveyard shift, whoever it may be, but whoever generally tends to just work. I want to be able to assess any possible workforce you can think of. And so, I like I said, I just really, really like Smart Eye for being able to be convenient, being able to give me on the fly, truthful information for what I present to participants. And it gives me the ability to not have to sit there and burn through a whole bunch of paper and ink trying to take every individual response that someone puts on a questionnaire, transfiguring it into SPSS, and then doing a data analysis. It just gives me the ability to just skip a whole bunch of that work. But it also, especially because Nam brought it up earlier, it also gives me the ability to kind of belong in those conversations regarding neurology, because like I said, my degree is more towards the social aspect. So this gives me like a sort of ability to both be in the conversations between laymen as well as the researchers, as well as hopefully future collaborators. And so I do appreciate that, both that, I guess you say, the convenience and the efficiency at the same time. And so I think that'll be all for me. I guess you can go on to Rick.
Hi, everybody. Thank you for participating. My name is Rick Ferraro. I'm a distinguished professor of psychology at the University of North Dakota. I'm finishing up my 32nd year here with probably 10 or 15 more to go. And my slide is very simple because when I was in graduate school back in the 1980s and early 1990s, I was involved in not only work in my discipline, which is cognitive psychology and information processing, but also human factors research. I did studies back then looking at how we read text on a computer screen. Sounds ancient nowadays, but that's kind of where we started way back when. And I just have, I'm more interested also in the research that we can do. And we've already discussed how Smart Eye and Eye Motions can help us really get into the future of this kind of research, especially with eye tracking. I mean, eye tracking is not new. It may sound like it's, newfangled and brand new, but it goes back as far back as 1879. People back then, of course, they didn't have the equipment we have now. They were interested in how people read. Probably one of the most significant texts in how people read and how you teach people to read comes from E.B. Huey way back in 1908 in his seminal textbook. But back then, they were looking at how the eyes moved, where the eyes fixated, what the saccades were like. And you can imagine doing research, over 100 years ago without the technology we have today. But believe it or not, Huey's research is still cited in 2023 and was prominent in the work I was doing back in graduate school. Now, since graduate school, I've delved more into human factors. Again, my background is information processing, cognition, word recognition. I'm really interested in the first couple of milliseconds of what people look at or process. And of course, the work we're doing now is very similar to that. The pictures I have up there, the one on the right is actually from the 1960s. So imagine trying to do that research in an automobile or whatever out in the real world. You just couldn't do it. The middle picture is a little more updated, and then the picture on the left is where it's totally unobtrusive. You don't have to put anything on your head, even though that certainly helps. And as Montel talked about and others, we fast forward now to the 1980s where people were kind of discovering, hey, we have this eye tracking equipment. What do consumers do when they're at the grocery store? And of course, that leads to, well, here's where we're going to place products. I mean, the next time you go into a grocery store, clearly the grocery store isn't set up in a haphazard, random way. Things are in certain locations primarily because of where you're looking. What are you looking for? What are the colors? What happens to be your emotion at that time? If you're really hungry and you're in the grocery store, you're going to be looking all over the place. And again, this work that we're doing now can translate definitely into that more applied kind of research. And there has been a lot of application more recently in the safety issues. Where do you put exit signs? Do you like the exit signs? What color are the exit signs? To things like rapid transit. What kind of information do they portray? If it's vocal information or auditory information, that's also critical. So as some of the previous speakers have said, more multimodal. The more you interact with the various modalities, the more real world, the more applied, the more realistic the outcome is going to be. So we see advances in aviation. I've done work also in aviation and air traffic controllers. Where do they look? What do they look at? How long do they look at that? And those are instances of where you have to kind of tamp down your emotions. If you've ever been on a plane and they're going through some turbulence, you don't hear the pilot yelling and screaming and all that. He or she keeps a very level emotional tone because that's what is shown to be most effective in those kind of emergency situations. We see it now, obviously, in automobiles with where to put the displays, how to locate the displays, even to the extent of involving an atypical research group, that of older adults. I do work with older adults across all domains in cognitive psychology as well, and they are people who want to keep driving. So you modify not the person, you modify the device to interact with the person so they can continue to drive, and more importantly, to drive safely, not have accidents, things of that sort. And our research is also relevant there because the research we gain, we can now train individuals. Here's the best way to look at a certain scene or a certain scenario. Here's where not to look. I mean, that's often not a question one asks. We're interested in where do you look when something happens while you're driving or whatever, depending on the vehicle. If it's a challenging vehicle, if it's you're on a dirt road and you're on a paved highway, the wear and tear of the vehicle, as well as the wear and tear of the driver and the passenger as well. So we have this kind of synergistic interaction amongst many different levels, the basic information processing all the way up to various emotions. And again, the Smart Eye and iMotions can readily and adequately handle that information.
All right, I'm back. All right, great presentation, super fascinating. We already have a few questions to start. What is the difference to go from a normal eye tracker to a driver eye tracker? What are all the aspects we need to consider? Is it similar to a driver monitoring system?
Our case, our systems, we differentiate from our research systems to our production systems. Today, SmartEye has over 2 million vehicles on the road utilizing our algorithms for driver monitoring. However, on the research side, in the case of UND, we're testing driver, we're testing passengers, and it really depends on what the client's looking for. The SmartEye Pro platform is versatile, can work in a number of different environments. So it really comes down to having that discussion with our client, like, what are you looking for? What's your environment? What are you trying to accomplish? So the multi-camera systems are utilized in a research base. Typically, your driver monitoring systems are 1 to 2 cameras.
And I think the question may also have been centered around, I mean, there's other ways to do eye tracking. There's wearables, there's screen-based. So I would just say that, it's a sliding scale of flexibility and adaptability on a wearable system. And then if you need more granularity or exacting data, you've got to go more to a fixed camera and a fixed real-world model location. So then you would move into a screen-based system if you're primarily operating on computers to get a higher level of accuracy. And then in the automobile, one of our big requirements was we definitely wanted an unobtrusive system. We wanted something that was vehicle-based, that we could swap people out in, and it basically made the vehicle a research tool instead of an ancillary asset. And we wanted to be hyper accurate for the work that we had to do. And so I think it's a sliding scale. I think there's also some cost factors that go into that sliding scale. So it's just it's a give and take, like so many acquisition and purchases are. You just got to look at what you have and the tools that are out there and what best suits your research needs.
There's also, I think, a number of environmental variables that happen inside the car environment, and on things like the sunlight, which will need to be taken into consideration when you scope out a particular package like this. Another thing is vibration. It wasn't until meeting Phil on site that I realized that this system might be airborne for certain periods of time. And then we'll have to sort of deal with making sure that this Humvee was going to be intact for those types of situations.
Nice. That kind of leads into another question I have, and this one might be more towards Rob. Based on what you've seen, what would you say some of the biggest challenges are in terms of eye tracking for research labs?
Sure. So field of view is one of them, and that's what makes the multi-camera system nice. As Nam mentioned, the sunlight, darkness, a lot of other eye tracker systems will lose data when you get into sunlight or darkness situations. So that's something to take into consideration. Just having the flexibility to be able to move, side to side, forward and backward, have that large head box is something to consider as well. I think that pretty much covers it. Also, I think I mentioned earlier, and maybe I can drive home that point, being able to utilize that 3D model to tell you exactly what your gaze is intersecting saves a lot of time for researchers. That's one of the biggest complaints I get from researchers in the field is, eye tracking is nice, but the data is either not usable, not accessible, or we have to do a lot of post-processing to utilize it. And so that we try to take care of those things.
Another question, I'm not sure who this is for, so feel free to jump in. What are the key factors that should be considered when dealing with multiple screen systems for a control room operator in industry?
I mean, for that one, for me, it would be, again, a cost factor of what can you equip. Is it something that you want in a real life implementation? So you're looking for something that's unobtrusive and constant. How fast do you need the data back? Because it really just is a number of cameras, like Rob and Nam have really alluded to, that in that sense, you probably could have just 3 screen-based systems as long as they were all calibrated and fusing the data together into one model, or somebody at some point was fusing the information together. So I think it's a tailorable system. I think it's definitely, in a system you could put together with off-the-shelf components that Smart Eye and iMotions would have. So I don't think it's an unobtainable system at all, but just a fun opportunity.
No, we do control rooms today. One of the things that we just recently implemented was combining our precise gaze and the AI gaze together. So precise gaze is where we use the infrared corneal glints from the infrared lights off the eyes. So we have to see those glints to do precise gaze. That gets us down to about a 0.5 degree of accuracy. Or we can utilize the AI-based gaze, which utilizes the iris and the head position. Now, it's not going to be as accurate as the precise gaze, but in a control room setting, there may be some areas on the outside of the control room area that maybe you don't need that precise gaze. You just want to know, are they looking down in this section or that? So sometimes you can get away with not using as many cameras, which of course helps reduce costs. So there are many applications that we do a lot of tracking in control rooms and air traffic control and things like that.
And I will add on to that, because that in some other projects that we're looking at and proposing, that really comes down to what's on that screen. If it is a single instance of information or only one type where it's not changeable, then that really simplifies the problem set, because then in your analysis, you can say that person was looking at this screen that provides this information for this long. So maybe you don't need an accurate where were they looking on there. But if it's a configurable display, if it's a software defined environment, if has multiple data points on it, then you're going to want that camera to differentiate where exactly were they looking and for how long.
Okay, another question. This one is for Nam. Can you speak on the capabilities of additional sensors like EEG, motion sensing, potentially audio or voice for the iMotions Research Lab solution?
Absolutely. So when we're looking at the types of questions that the researchers such as Montel are looking for, each type of sensors will give you a percentage of the insight. So something like, eye tracking again gives you that attention. But when you're looking at something that's more of like a complex decision-making factor, the more information that you can kind of glean from the subject, the more sort of that variability you're able to account for. So things like a facial expression in the moment might be very telling about how they're feeling, but facial expressions with, say, a heart rate or something else that gives the information about how much emotion they're feeling might give you some indicating understanding of the veracity or the intensity of that felt particular emotion, whether they're trying to execute a particular set of instructions, navigate a task, encounter some sort of standardized product where they actually need to make some sort of decision-making tool in the end. If you start layering in some of these other signals, such as using AI-based voice detection emotion, so you can just take a look at, does this person sound stressed or happy? You could take that information and actually transcript it into specific words and do analysis on that. All of which, when you're looking at these complex behaviors such as teamwork, team efficiency, human state, it's going to give you a little bit more insight into each one of those. And then as you drill down, you can start layering on lots of things, like how tense is the person in particular areas? How much movement are they doing? How hot is the person? Maybe people that make perfectly rational decisions when they're nice and comfortable in a nice AC environment, when you stick them out in the hot desert, all of a sudden can't deal with situations nearly as good as they did before. Or if you freeze them down until they're super cold. So again, getting situational awareness beyond what is just like generalizable within the laboratory will help sort of kind of build the machine and human understanding so that they work together better in the future.
Yeah, and I can add a little bit to that as well. From a cognitive perspective, the more domains you have active at any given time, the more likely you're going to provide better data that will not eliminate crashes or accidents or whatever, but it will reduce those. So now you're providing information back to the user for their safety, as well as obviously the vehicle's safety. I've done some research with motion cueing in unmanned aerial vehicles, and the same thing applies there. The typical unmanned aerial vehicle, the sensor and the operator usually sitting at a table in a room, much like my office, in a chair, much like the chair I'm in. And the research is pretty clear. If you add in a motion cueing chair that you sync up with the environment, so if the UAV is going down or going up or going to the left or the right, if you provide those cues back to the human, In fact, it reduces reaction time, it reduces error rate, and the same thing can be applied to the work we're doing, regardless of the domain. I mean, our test participants, of course, were invested in their safety as well. They're going to be driving these vehicles perhaps for part of their career or their job. They certainly want to get as much information back as possible. And what's nice about these systems is you can give that information back in kind of a tutorial that says, well, look, in this situation, you looked over here and you really shouldn't have looked over there. We're going to try to retrain your system, or your brain, or whatever, or your body, or your senses, to ensure that the next time this happens, and it will, of course, happen a next time, that you'll be better able to handle that situation, especially if it comes up where you don't expect it. I mean, a lot of times in these testing sessions, they're in a lab, a very sterile lab. There are no automobile accidents in the lab, but you can certainly program the system to be an aviation, automobile, whatever, where you build in kind of a almost a death scenario. You're driving down the highway and your tire blows. I mean, that doesn't happen very often, but when it does, what do? Where do you look? How fast do you make decisions? Well, in these situations, you can now mimic that, provide feedback, which results in safer performance, a reduction in cost of performance, and all sorts of positives that you're not going to get with other types of systems, for sure.
Great, thank you. So this is a good one. For detection of cognitive workload, is there any academic reference, such as research papers? I sense this is a group that would appreciate a good academic paper to support the effectiveness of eye tracking or gaze.
Oh, I could supply you with several, part of another project I'm working on. I can't say too much about it, but it's with the FAA, and we're updating their training manuals regarding workload. What is workload? How do we define it? We've come up with several definitions of it, and there are seminal works in workload that go back, several decades. I can certainly offline fill you in on those sorts of references, certainly. I mean, in fact, a lot of workload analysis grew out of very applied work in the Second World War, signal detection. Do you pull a lever to drop a bomb, or do you push a lever to drop a bomb? That's a pretty important decision if you make a mistake. So this modern day workload, as it relates to eye tracking, goes back several decades, and I'd be happy to update you on that information, certainly.
Rick, can I ask, is pupillometry a part of that workload analysis?
Yeah, pupillometry, I mean, it is, because the way your pupil reacts to light or to stimuli, mostly visual, but also other senses, is really seen as kind of a window into what you're thinking of, what you're paying attention to, or if you have to focus your attention. You're driving. Here's a classic example. You're driving and you are in nice sunny weather, and all of a sudden you hit a snow squall and everything literally changes in a few seconds. You notice your pupil gets smaller. You pull in more information. You're very focused to the extent that you're not hearing or seeing other kinds of stimuli because of the focusing of it. But there is a lot of pupillometry research still being done, and that goes back to the 1960s and 1970s, the initial papers on that. So it's still a pretty viable tool.
All right. Another question just came in. For the eye tracking cameras, does the software you use create the 3D environment that come with the cameras? Is that something the Smart Eye Pro software has mentioned above?
Yeah, when we provide a system, it comes with a chessboard that you see here, and the camera system each camera recognizes this chessboard pattern, so it can determine the distance and the angle of the chessboard, and then we connect that with a laser tool. So basically you shoot all of the items, like let's say three corners of the windshield, and it'll draw that plane in space in relationship to the cameras. You shoot the center of the tachometer, the outside radius, you shoot that, it'll create that circle. You can do circles, cylinders, spheres, all kinds of different shapes to create whatever environment you're working in.
One question I wanted to get to and this is for Phil, I think, in the UND team. Can you discuss what kind of post-sale support you received? So maybe Rob can comment on that as well, but from the Smart Eye side.
Yeah. We bottom line up front, it was outstanding. We set a pretty audacious goal and timeline that we wanted to go hard and we wanted to win fast. And so we've acquired, UND has its own Humvee now. We wanted it outfitted with the system and we wanted to be in the field using it on the timeline that we had planned for. And it didn't allow us a lot of prep time and a lot of risk reduction. We built all of that in to the actual event when we were in the field. And as part of that, we invited the entire Smart Eye team out to embed with us in the field. And it worked wonderfully. Our Humvee did have some mechanical issues. And it's an older vehicle. It's cool. We solved those, but we put ourselves a little bit behind. The Smart Eye team was working long hours and into the dark to get the system up and going. The Humvee is not an easy vehicle. It is not designed to be smooth riding. It is designed to deliver things to where they need to go and to crawl and motor over non-normal obstacles. So it's different, and it was a challenging install. And the more we stress tested it out in the field, the more issues we had to resolve and come up with, and we've done that. But I'll hand it off to Rob and Nam for their inputs about being on the receiving end of having to deliver all of that. And I believe Aaron was out there with us as well, but they were out there sweating with our entire team the entire week. And it was very, very warm, and there's no AC in that truck. So
I think it was plus 100 something degrees out there, but
index was 105 one day. Yeah, it was bad.
So when we sell a system on the research side, we're very hands-on, and I always tell my customers that we're going to come to your facility, spend a couple days with you guys. So we'll install the system, and then we'll spend a day training you on how to install it yourself, how to create the 3D models, how to troubleshoot. And I was very impressed, I have to say, with the UND students to how quickly they picked everything up. When we came out for the field study, it was amazing how much they had already grasped. And so we were very pleased about that. Of course, we had to work out some challenges with the power supplies and in the vehicle and things like that. But we've been able to work through all that, and everything's up and running.
It was just a ton of fun, lots of challenges. One small mushroom cloud without any sort of a contact center. Not our mushroom cloud, not our project. It was the next range over, but it did appear. Lots of bugs, both software and actual giant bugs in the Humvee. So it was a fun, challenging time, and I enjoyed every minute of it. Thank you.
But we're still friends.
Listen, we all grew. We grew. Okay, perfect. So that is all we have time for. We're way over. I want to thank all of our presenters, Rob, Nam, Phil, Montel, Rick, once again for making the time to share this with us today. And hopefully this gave some clarity on the amazing work Smart Eye Together with iMotions is doing for researchers. Follow us on social media, sign up for our newsletter so you don't miss out on our next event. And thanks, everyone, and have a great rest of your day wherever you are in the world.
Thanks, everybody.
Thank you.
With a comprehensive Smart Eye and iMotion setup featuring multiple cameras, EEG data collection modules, and emotion sensing capabilities, the team at UND RISE really showcased the true potential of eye tracking combined with other biosensors in understanding driver and passenger behavior, enhancing research capabilities. I hope you enjoyed today's episode. Don't forget to subscribe to the Human Centric AI podcast on iTunes, Spotify, Amazon Music, or wherever you get your podcasts for new episodes. We are also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag HumanCentricAI Podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.